When we say that cities are sinking, we're often compressing several different physical processes into a single phrase. But what's actually happening in most cases is land subsidence, the gradual lowering of the ground surface due to the changes in the material beneath it. Cities including Jakarta, Venice, Bangkok, Mexico City, New Orleans, Shanghai, and Ho Chi Minh City are all subsiding, but for different reasons. In many cases, the dominant driver is groundwater extraction. This is where pumps enter the picture. In low-lying or below sea level cities, gravity alone is no longer sufficient to drain rainwater or floodwater. Pumps provide the energy required to move water uphill out of streets, canals, and basins and into rivers, lakes, or the sea. New Orleans also relies heavily on pumps because much of the city cannot drain by gravity, especially when levees and flood walls limit outflow routes. But there is an important limitation here. Pumps do not prevent subsidence. They do not replace lost sediment or restore soil structure or counteract compaction, which brings us to the case of coastal Louisiana and the recently cancelled Mid-Barataria Sediment Diversion Project. Unlike pumps, sediment diversions are designed to change the mass balance of the landscape. The Mississippi River carries enormous quantities of sediment, which historically spread across its delta, gradually building land and offsetting natural subsidence. But levees that were built for flood control have cut off this sediment supply, leaving wetlands and coastal land to erode and sink. The Mid-Barataria project aimed to partially restore this process by redirecting river water and the sediment that it carries into adjacent basins during high flow periods. Now, Louisiana is losing land fast, among the fastest rates in the world. And while pumps keep areas dry, they do not stop the land from disappearing. So this plan would not have been a short-term fix, but a long-term structural intervention that is desperately needed. Unfortunately, it was cancelled for various reasons, including high costs, litigation, and objections from fishing communities, stopping what many have described as one of the largest single ecosystem restoration efforts in US history. And the cancellation of the project underscores a broader tension in managing sinking landscapes. What needs to happen versus what people want. Pumping systems offer immediate visible control over water, while sediment-based solutions operate slowly and unevenly and often conflict with existing land uses and economic interests. Pumps can manage water levels, but they cannot rebuild land. So addressing sinking cities in the long term ultimately requires distinguishing between hydraulic control and geophysical restoration, and deciding how much effort we're willing to invest in each in order to stop our homes from sinking and protecting them for future generations.